Welcome to this video on characteristics of functions. By the end of this video, you should be able to define continuous, discrete, domain, range, increasing, decreasing, x-intercepts, y-intercept, zero, maximum, minimum, and rate of change. You should also be able to identify continuous, discrete, domain, range, increasing, decreasing, x-intercept, y-intercept, zero, and rate of change from a graph. All right, so we're going to have all of these characteristics that we're going to try to name and to describe our graphs. So continuous means contains every number, so that is connected by a line. Okay. Discrete means disconnected elements, not containing every number, so you can see the individual points. So the domain is the set of all x values, which we could also call the inputs. It's what you would plug into an equation. The range is the set of all y values. They're the values you get out when you put in an x, so they're called outputs. Increasing means the graph goes up as you go from left to right. Decreasing means the graph goes down as you go from left to right. The x-intercept is the point where the graph crosses the x-axis. The y-intercept is the point where the graph crosses the y-axis. A zero is the point where the graph touches the x-axis. It could also be called a root, a solution, or your x-intercept. So your x-intercept and your zeros go together. They're pretty much the same thing. Your maximum is the highest y value on the graph. Your minimum is your lowest y value on your graph. So you'll see them show up in your ranges too, because they're mentioned in the ranges. And then your rate of change is the ratio of the change in y to the change in x over a certain interval. Remember that rate of change is the same as slope. So you would do the y2 minus y1 divided by x2 minus x1. All right, we're going to take all these vocabulary words and we're going to start to apply them to some different graphs. So let's look at our first example here. We're seeing individual points. These are not being connected together. That means this is discrete. When you have a discrete graph, you can name the actual individual x and y values. So for my domain, my smallest x value is where x is 0. Then I have where x is 2. And then I have 1, 2, 3, where x is 4. We only want to list the x values, and you want to put them in order from the smallest x value to the biggest x value. So that's easy. We can start on the left and go right. And remember, we're only naming the x value. So where x is, on this point, x is 0, x is 1, and x is 4. Now for our range, we read the graph from the bottom to the top. The lowest y value is at -1. The next lowest is at where y is 2. And our next one, if you count all the way up there, that's where y is 7. And again, we went smallest to largest. So that's what, if it's discrete, you have to list them individually. But if we look at this graph is continuous because it's connected by a line. Okay, we can't name all of the x values and all of the y values, so we have to use inequalities. So my domain is from the left to the right. So the left-hand side of this graph is where x is 0. So I'm going to put where x is 0. But this graph is never going to stop going to the right. So when you only have one number like that, this really goes to infinity forever and ever and ever. All of my x values, if they're going to be on this graph, have to be greater than 0, but they could also be equal to 0 because we have a closed circle there. So all my x values are greater than or equal to 0. Okay, so that's domain, left to right. Now, range is bottom to the top. So the very bottom y value is -1, but it never stops going up. We only have one number, so we got to say how y relates to that one number. All the y values are above that number, so y values are greater than or equal to -1. All right, now the minimum and the maximum are new here. So let's look back up here. So it says the minimum, which is what we're trying to find. The minimum is the highest y value, or sorry, the lowest y value point on the graph. Okay, so when I look at my graph, the very lowest point is this point, and my y value there is -1. So I'm going to say y is -1. I want to see now my maximum, that's my highest y value. But this graph never ever ends. I'm never going to have a maximum y value, so I'm going to say there's not one here. Don't write 0. 0 is a number. I'm saying there is no maximum because it goes up forever and ever and ever. All right, let's try some of these on the other side. All right, my first question here, is it discrete or continuous? This is connected by a line. That makes it continuous. Okay, our domain is our x values left to right. I do have an exact left and an exact right because there's points and not arrows. My lowest x value is at 0. My highest x value is at 10. We're talking about x's. And these are closed points, so they're going to be equal to. And let's try this for our range. Our lowest y value for range, these are at the same level where y is 0. My highest y value is up here where y is 7. We are talking about y's, and it's a solid line, so we're going to have equal to as part of our inequality. The minimum, what's the lowest y value? Well, the lowest y value is 0. We just said that in our range. So the lowest y value is 0, and our highest y value is 7 because we said all the points are between 0 and 7. So that's range is directly related to your minimum and maximum. All right, x-intercepts. I want to know the name of the points where the graph crosses or touches the x-axis. So we touch the x-axis here at 0, 0. And we touch it again over here at 10, 0. And then our y-intercept, the name of the point where the graph crosses the y-axis, is also 0, 0. All right, try pausing the video, see how you do, and come back once you've completed this. All right, this is a continuous graph because everything's connected with a line. Our most left-hand x value is -5, and our most right-hand x value is 10, so that's our domain between -5 and 10, and it's equal to because these are closed circles. Our range, our lowest y value was -4, and our highest y value was 10, so we're saying the whole graph occurs between -4 and 10 for the y's. Now remember, our range is directly related to our minimum and maximum. Our minimum is -4 and our maximum is 10. For our x-intercepts, this one didn't go through exactly, so I kind of estimated it to be -3.25 because it was -3 and a little bit further, 0, and then on the other end our x-intercept is at 10, 0. And then our y-intercept occurs right here at 5, 0. All right, one last one. So this says graph this function for these x values. It means for only those x values. So this is going to be a discrete function. We're going to have points. So let's take the 0 and plug it in. So we get 0 plus 2, which will give us 0, 2. So I'm going to plot that point, 0, 2. If I plug in the 1, I have -1 plus 2, which will be 1. So there's 1, 1. If I plug in the 2, I'll have -2 plus 2, which is 0. And if I plug in the 3, I have -3 plus 2, which is -1. Now, if we really think about it, this is our slope. Our slope is -1. Down 1, right 1, down 1, right 1, down 1, right 1. That's our constant rate of change. But I only wanted it for those 4 points. I don't want to connect them because this is going to be discrete. So I'm going to have discrete down here. Now for my domain, those are my x values in order from smallest to biggest. So we had 0, 1, 2, and 3. That's what they asked us to plug in. The range is what we got out when we plugged in, and so my lowest y value is here at -1, and then 0, and then 1, and then 2. So that's my range. Remember, you see individual points, you have to tell me individual x's and individual y's. My y-intercept occurs right there, and the name of that point is 2, 0. Oops, let's change that. It's not 2, 0, it's 0, 2. Sorry about that. You got to have your x value first and then your y value. Okay, so we didn't go left or right, we only went up. My x-intercept, we have to go right 2, but we don't go up at all, so that's 2, 0. I got ahead of myself. Okay. All right, so when you're discrete, remember you have to list the individual x's and y's, but when it's continuous, it's not possible, so you can only tell it where it starts and it stops. All right, if I wanted to, I could ask you, what's the maximum of this? Our maximum here would be y equals 2, which we see there. Or a minimum would be at y equals -1. So you can see your range is directly tied to your maximum and minimum. Hopefully that was helpful. Let me know if you have any questions. See you in class.